Okay. So we have two main objectives today. Our first objective, I'm going to write these on the board, is algebra objectives. The first thing we're going to talk about today is called the zero product property. Now, this is actually not new information. The zero product property says that if you're multiplying two things together and they need to equal 0, that one of those numbers needs to be 0. Okay, so that's the first thing we're going to talk about today. And then we're going to introduce what the term factor means. And we're going to factor by GCF. Okay, bonus question, going back to middle school here. GCF, does anybody know what that stands for? Oh, Jeffrey?
Greatest common factor.
Beautiful, greatest common factor. So we're going to learn some greatest common factor today, which is why you have this super nifty factor sheet. Oh, we're not going to complain about this because this is a blessing and a privilege. Because when I ask you questions in this section, like, hey, Dominic, give me two numbers that multiply to 42. And Dominic's like, crap, I don't know. All he has to do is go here, and here's all of the things that multiply to 42. So it's taking a lot of that work away for you, okay? So this is a good thing. This is a blessing, all right? It only goes up through 100, but that's going to be a blessing too. Now, before we get to that, I want to explain also what this word or phrase factor means. So I'm going to try to work backwards a little bit here and pull off of stuff we've done before. So the first thing I want you to write down today is, we're just going to get nice and warmed up here, and we're going to multiply this together. So go ahead and write that down. And we are going to multiply this together. Okay, so when we have a monomial times a binomial, we distribute. We don't really set up a box method because it would just be one box for just the 3x. Now, 3x times x, let's see how well we remember what we did yesterday on the quiz. 3x times x. Any volunteers? Sharon? Is not 4x. That would be plus. Sammy? 3x squared. So 3x the second power. No worries. Whenever you have an x times an x, that increases the exponent. 3x times 2. Who'd like to raise their hand and volunteer that one? Joshua? 6x. And that would be your answer. Lovely. Okay. We're going to do one with two binomials. This will be a good practice for those of us that maybe didn't do so hot on the multiplication part. Now, you can do distribution, which is what some of you did. No problem. Or you can do box method. I'm just going to do box method off to the side. Only because those of us that aren't super great with multiplication stuff, I do think box method helps keep it a little more organized. Okay. I'd love to hear from some new folks. X times x. Yara? X to the second power. How about x times -1? Someone new? Josiah?
-1x.
Beautiful. How about 3 times x? Someone different? I've heard from Jeffrey, though I appreciate you. 3 times x. Be brave. Maddie?
3x.
Thank you. And our last one, 3 times -1. Somebody new. Richard? Lovely. And then you can go ahead and add those like terms together, those x's, to get a final answer of x squared. Oh, somebody help me out. What's 3x minus 1x? I'm gonna make someone new answer. I'm looking at my quiet table of 5 over there. 3x minus 1x. 2x, thank you. Minus 3. Okay. So that is stuff we've already done. That's the multiplication part. So factoring, this right here is called factored form. Okay, same with this. All of this right here is called factored form. So, what we are doing for the remainder of the chapter, which is a little more challenging, not impossible, is you're going to be starting with this part, and you have to figure out what multiplied to make that. So it's like a puzzle. You have to work backwards. Now today we are only going to be doing things like this. We will get to this part tomorrow. So today we're going to start with something like this, and we have to think, what distributed through here to get to this final conclusion? So we're going to be factoring out a greatest common factor and getting it back into that factored form. So again, this whole concept of factor means you're starting with this and you're working backwards to make this as your answer. Okay. Before we get there, I also want us to write down, because this might come up, just some vocabulary. So solutions, zeros, and roots. I think the word is pronounced roots, but for whatever reason, that word really bothers me. I hate that vowel sound. I don't, it's just makes me cringe. Roots. Also, this is super not related, but you know the word greasy? How do you guys say the word greasy? Greasy. Okay, my mom says it greasy, and it makes my skin crawl. I'm like, ugh, don't say it like that. Okay, that was totally random, but. The other one we're not going to see now, but we will see down the road, is x-intercepts. You don't really need to know specifics here, except that they're all kind of the same thing. They're not literally the same thing. There's a reason they have different words. But you're going to get directions that say, find the roots. And that just means find the answers, find the solutions. So people always what are roots? Okay, roots are just the answer. So they're all kind of the same thing. So I'm just going to write in here, it's the answer. Same with zeros. Does zero have an E before the S? Zeros. No. No. Okay. Okay, so the first thing we're going to talk about today is the zero product property. So we just finished talking about that. We said if anything is going to multiply to make 0, then one of the numbers has to be 0. So if you have two things that multiply to make 0, then one of these must be 0. The only way to multiply to 0 is if you multiply by a 0. That is the only way. We're not talking about addition and subtraction. We are talking about multiplication. The only way to multiply to 0 is if you multiply by 0. So the first thing we're going to do today is we're going to start with something in factored form. So it's already factored for us. Eventually, we have to factor it and solve it, but for today, they give it to us factored. And all we have to do is set each factor equal to 0. Grab my coffee. Okay. So, first couple of examples. These are already in factored form, and I want to make sure we understand that. So these are already what we call factored. They're already factored. And factored again means like they're already written into individual pieces. Like this is a piece, this is a piece, that's a piece, that's a piece. Like they're already separated. So if they're telling me that 2x times x minus 4 equals 0, then one of these has to be 0. So when they say solve this equation, all you have to do is set each factor equal to 0 and solve. Okay, and I will obviously explain that better in just a moment, but that's like the how-to. You're going to take each factor, you're going to set up like their own separate equations equal to 0, and you're going to solve it. So again, if this multiplied this equals 0, then either this one needs to be 0 or this one needs to be 0. So either 2x needs to be 0 or x minus 4 needs to be 0. One of them needs to be 0. So you just take each factor, set them equal to 0, and you solve. Okay, make sure you're writing this down. We don't want to check out on this section because it's going to get real hard if we do. All right, this is chapter 1.1. Like this is solving for x. We have done this a gazillion times this year. We can divide by 2. What is 0 divided by anything? Okay, so that's one of our answers. Over here, we would add 4 to both sides. What is 0 plus 4? That's our second answer, and you're done. Those are your two answers. Pretty easy so far, right? Now, again, this is fairly straightforward. Eventually, you have to factor it first and then set it equal to 0. So it takes a little more work, but they're just kind of breaking it up into parts for you right now, kind of what we call scaffolding the information. Okay, so letter B is the same thing. You have two factors. They're telling you this times this equals 0. So that means one of those numbers needs to be 0. So either x minus 3 needs to be 0 or x minus 9 needs to be 0. And I just like, you don't have to put the bar in the middle. That has nothing to do with anything. That is just something I do to like separate it as two problems basically. They're both answers though, so it's going to have more than one answer. We will see one in a minute that only has one answer, but usually there's more than one. Okay. So that's just a quick little solving. We're going to add 3 to both sides. So our first solution would be 3. And we add 9 to both sides. And our second solution will be 9. Now again, I do think there's some of you in here that maybe don't need to show all of that work to get the answers, and that's okay. I will tell you guys what happens, especially in like with my geometry students, is people will write -3 and -9 as the answers. No, it's not. So you have to still set it equal to 0, but I would say when you set it equal to 0, I do think some of you can probably do that in your head pretty quick without showing work, which is fine. Just make sure that you do that step. What questions do you have right now just about setting the factors equal to 0? Cool. We're going to do just a few more. We're going to do one that has a little bit more than just x. That's okay. You just might have a decimal. We're going to do one that only has one answer, and then we'll do quickly one that has 3 answers. Okay. So the first one, again, is already factored for us. So we're just going to take each factor. They are different. They look very similar, but they are different. So we're going to take each factor and set it equal to 0. So we have 2x plus 7 equals 0, or 2x minus 7 equals 0. Okay, it's a two-step equation. We haven't done something like this in a while. Who can raise their hand and tell me what the first step is to getting x alone? Sammy, go for it. Very good. You got to move that constant to the other side first. We drop down the 2x. 0 minus 7 is negative 7. I'm trying to think. I haven't heard. Richard, go ahead. Good. So when we divide by 2, he's exactly right. And thank you, those of you that picked up your calculator and you chose to double check that. Thank you for doing that. But it does equal negative 3.5. Or if you'd rather leave it in a fraction form, sure, go for it. Okay. So same thing over here, except this time we're going to add 7 to the other side. 2x equals 7. Now add my 2. 3.5. So I know I kind of rushed through that, but that's because that's like chapter 1. That's just a two-step equation. So I can't spend a ton of time doing two-step equations. So your answers are positive 3.5 and negative 3.5. B is an interesting one, right? It's just x minus 1 squared. So from yesterday's quiz and from the sections before that, remember that x minus 1 squared is the same as x minus 1 times x minus 1. So this technically has two factors. Okay, it has two factors. But since they're the same, do you really have to put x minus 1 equals 0 twice and get the same answer twice? No, you just need to solve it once. So if they're the same, you can just set up one equation. You don't need to set up two because they're the same thing. So that would be silly for you to do the work twice. Dominic, what's my one step for getting x alone?
Make minus plus below 3 by side.
Very good. So that one only happens to have one answer because it was the same factor. And our last one has 3 answers. And these are types of problems that I can do like just pretty quickly in my head because I know it's just going to be the opposite, the opposite, the opposite. So like I can just write out the answers. But if not, you're going to take each one of those factors and set it equal to 0. So here's 1. Here's the second one. Here's the third one. Right? The answers are not 1, -3, -2, because you still have to solve and actually get the x by itself. So first one, we'll minus 1. We get -1 as an answer. The next one, we add 3. We get 3 as an answer. And our last one, we add 2. We get 2 as an answer. Okay, so again, where this is going is you're going to have to be the one to come up with the factors and then also set them equal to 0. So for today, we're just kind of concreting that when you solve it, each little of those factors is set equal to 0. Any questions? Okay, so then the last part of today is this concept of greatest common factor. I do feel like we do pretty well with greatest common factor with numbers. So if I asked you guys, What's the greatest common factor, for example, of like 10 and 15? Just because I know some of us are coming from places that don't know what greatest common factor is. This is how I describe greatest common factor. Greatest common factor is the largest number that can evenly divide out of both. One singular number that will evenly divide out of both of these. Saw Sharon's hand first. 5. So this would have a greatest common factor of 5 because it's the biggest number that can evenly divide out of both without decimals or fractions. Okay? What if I did 18 and 27? Good. Now, if you were thinking 3 is a common factor. That's true. But the greatest common factor would be 9. Now, here's where your little sheet comes in handy. So, if I said, hey guys, what's the greatest common factor between 18 and 27? And one of you sitting in here going, what the heck? How are people getting it so fast? Look, here's all you have to do. Don't do this on your paper because you don't want to get messy. Here's 18. Here's 27. Now, the factors, you guys, are separated by these little semicolons. So, like, 1 times 18, you can't see. 1 times 18 equals 18. 2 times 9 equals 18. 3 times 6 equals 18. So those are your factors. So when you look at your factors of 18 and 27, you're looking for the biggest number that they have in common. So, like, they both have a 1. They don't both have an 18 or a 27. They do both have a 3, but the biggest number they have in common is 9, and that's the greatest common factor. So you can find that greatest common factor even if you don't know how to do it just in your head using this sheet, okay? So those of us that, again, maybe struggle with our number skills a little bit, this sheet's going to be your best friend. Yeah? Okay. Now, the tricky part, the part that's new from middle school, is now we're going to add in variables. Here's kind of the rule with variables. So if I asked you guys, what's the greatest common factor between x squared and x to the 5th? Okay? It is the biggest number of x's that you can evenly divide out of both. All right? So remember, x squared is x times x, and x to the 5th is x times x times x times x times x, 5 x's. I want to know what's the biggest amount that you can evenly divide out of both. Okay? Sammy's holding up 2. You can divide 1 away from both of them. You can divide a second away from both of them. But that's where it cuts off, because if you add any more, you don't have anything on top left to divide. So the rule of thumb for variables is whichever's the lowest exponent, that's how many you can take out. Okay? So the lowest exponent equals your greatest common factor. Okay, that's how many you can take out. So, before we put all this together, I'm going to give you one more example. I'm running out of space here. That's all right. Okay, that's my last one. Now, this has an exponent of what? 1. So which one of those is the lower exponent? Then that's your greatest common factor. That's the most you can take out. You can only take out whatever is the lower exponent. Okay? Does that kind of make sense? That's for variables. You won't have one. You shouldn't have one. I don't think that has more than one variable. At least not tonight. Okay. So we're going to put all this together. We have the problem 4x to the 4th plus 24x cubed. Now, before I get overwhelmed, I just compartmentalize this. I start with the numbers, just 4 and 24. So you guys don't blurt it out loud yet, because I want people, some of you are quick with this, like what's the greatest common factor between 4 and 24, and you're super fast. Some of you need to go to your sheet, and you need to look at 4, and you need to look at 24, and you need to find the biggest number they have in common. So I'm going to give you like 10 seconds to do that without anybody blurting out answers, please. So you're going to look at 4. You're going to look at 24. What's the largest number they have in common? Joshua? 4. Okay, so 4 is going to be part of the greatest common factor, but it's not the only thing because the variables also have a greatest common factor. I just told you the rule. The most you can take out is the lowest exponent. So look at these two. Richard, what's the lower exponent?
3.
The 3. So you can take out x cubed, x to the 3rd. That's as many as you can take out. Now, what we're going to do is we're going to quote unquote undistribute. This is probably not a real word, but we've done distribution. Now I'm going to reverse that. When we distributed, what operation is that? Someone said it. Multiplication. So what's the opposite of multiplication? Division. So when we undistribute, you are essentially dividing these by that greatest common factor. Okay? I promise it looks worse than it really is. Now, who have I not heard from yet? Max, what's 4 divided by 4? 1. Okay. We have x to the 4th divided by x cubed. All you do is subtract exponents here. And so, Kylie, if I have x to the 4th and I subtract 3 away from that, I have x to what power?
1.
Just 1. Okay. Our plus sign drops down exactly as is. Let me go to the next one. Jordan, what's 24 divided by 4? 6. Okay. 3 minus 3 is just 0. That means all of the x cubes cancel out, and this is your answer right here. Now, if you were to redistribute that 4x cubed, guess what you would get? 4x to the 4th plus 24x cubed. Now, we don't usually write it as 1x to the 1st, so I'm just going to clean that up and just make it x plus 6. Oop, I cut off the 4, sorry. Okay, before you freak out, let's do it one more time. That's the answer. So you are undistributing and you're putting it into factored form. And once it's in factored form, you're done. Okay, I'm going to start with the numbers. So again, I want to give people a chance to look at their sheet if they need to. You're going to look at 8 and 24, and you're going to find the biggest number they have in common. Just going to give you like 10 seconds. Please don't blurt out loud. The biggest number they have in common. Jacob. Beautiful. So 8's going to be the greatest common factor for the numbers. And then we're going to take a look at our variables. Okay. We have to keep memorized the fact that when we don't see an exponent, that's really an exponent of 1. The most you can take out is the lower exponent. So, Jimmy, what's the lower exponent of these two? The 1. So you can take out a y to the 1st, or just y. That's all you can take out. Okay, and you're undistributing, dividing it away. Like pre-distribution. How did we get to this spot? So again, you have to think about that as like division. And some of you are better at doing this in your head probably. Some of you, I would just write it out. Okay, let's go. Lily, what's 8 divided by 8? And then we have y squared divided by y to the 1st. If we subtract those exponents, Jonah, we're left with y to what power? 1. Okay. We just drop down the minus sign. That always stays the same. Whatever sign was there is the sign that stays. Katie, 24 divided by 8. 3. And then those happen to cancel out. They don't always cancel out, but those, because they match, would just cancel out. So this is your answer. Now again, we don't usually leave it with all those ones. So like that's how you would see it written. And if you check that, right? If I were like, hey, Jeffrey, multiply that through and you were to redistribute, guess what you would get? That's what you would get, which is what we started with. So this is your answer. That's your answer, that whole thing. Okay. So I want you guys to grab out your homework. And I'm going to do, you guys only need to do 1 through 9. And I'm going to make sure I clarify a couple of things with you. Sorry, did we all have a chance to finish writing that down? Okay. Okay, so you can cut it off at 9 today because we didn't quite get to this part, which is fine. So this is all just, when it says solve, this is just setting each factor equal to 0 and solve. Okay? Set each factor equal to 0 and solve. 1 and 2 and even 6 are a little interesting because they have this just like random one on the outside, right? So let's talk about that. That counts as one of your factors. So like on number 1, you still have 2 factors even though one of them is just an x. So when you set that first factor equal to 0, guess what? That's one of your answers right there. So if you see a lone letter just hanging out on its own, that just means one of your answers is going to be 0. Because when you set it equal to 0, you get 0. And then we'd finish it off by minusing 5. Okay. Sorry, I'm probably going too fast. I'd say on the bottom it doesn't really matter. 7, 8, or 9, which one would you like me to do? Joshua? 9, sure. Did everyone have a chance to write that down? Okay. So let's take a look at 9. You can just set that on my desk back there. Thank you, dear. I'm going to start with the numbers. Okay. Who'd like to give me the greatest common factor for 8 and 24? Sharon? 8. Okay. Then I go to my variables, which again, you have to remember that an h by itself is h to the first power, not h to the 0 power. So what's the greatest common factor for h to the third and h to the first? H to the first, right? The lower exponent. Good. Which is just h. Now that's not your actual answer because you still have to factor it. And we're going to go ahead and factor that really quick. Oh, this is an interesting one. Was 24 divided by 8? Okay. H cubed divided by h to the first besides Yara. H cubed divided by h to the first. Somebody different. Sharon?
Wait. You do the 1 divided by 3.
So you just subtract the exponents.
2.
H squared. Okay. 8 divided by 8. 1. And then h to the first divided by h to the first just goes away. So there's your answer. We are not packing up until everybody does one more. The whole thing?